Hello and welcome to Virtual Learning Channel. As we know, generic was added from Java 5, so it is necessary to provide some transition paths from old pre-generics code. In addition, these transition paths had to enable pre-generics code to remain functional while at the same time being compatible with generics. In other words, pre-generics code had to be able to work with generics, and generic code had to be able to work with pre-generics code. To handle the transition to generics, Java allows a generic class to be used without any type arguments. This creates a raw type for the class. This raw type is compatible with legacy code, which has no knowledge of generics. The main drawback to using the raw type is that the type safety of generics is lost. Before starting, if you have not subscribed to my channel yet, please subscribe to my channel and also push like button to encourage me making more videos. Let's see an example. Here we have a simple generic class with parameter t. This is our class constructor and also setter and getter methods. Please notice that no type arguments are specified. This creates a generic class object whose type t is replaced by object. A raw object type is not type safe, so a variable of raw object type can be assigned a reference to any type of generic class object. The reverse is also allowed. A variable of a specific generic class type can be assigned to a reference to a raw generic object. However, both operations are potentially unsafe because the type checking mechanism of generics is circumvented. Here we will see some problem of this lack of type safety in our example. The value of object inside raw object is obtained and this value is cast to integer. The trouble is that raw object contains a double value, not an integer value. However, this cannot be detected at compile time because the type of raw object is unknown. So this statement fails at runtime. The assignment is syntactically correct, but questionable because a string object is of type generic class string. It is assumed to contain a string. However, after the assignment, the object referred to by a string object contains a double. So at runtime, when an attempt is made to assign the content of a string object to str, a runtime error results, because a string object now contains a double. So the assignment of raw object reference to a generic reference bypasses the type safety mechanism. Here, a generic reference is assigned to a raw object reference variable. This is syntactically correct, but it can also lead to problems. In this case, raw object now refers to an object that contains an integer object, but the cast assumes that it contains a double. This error cannot be prevented at compile time, so it will cause a runtime error. In this part, it is the call to the generic class constructor without a type argument that causes the warning. In the next line, it is assignment of a raw object reference to a generic variable that generates the warning. This line is also potentially wrong, and it will give warning of unchecked assignment. No compiler warning is issued because the assignment does not cause any further loss of type safety than had already occurred when raw object was created. You should limit the use of raw types to those cases in which you must mix legacy code with newer generic code. Raw types are simply a transitional feature and not something that should be used for new code.